Microsoft is betting big on Rust. It's being used across their product lines. We finally have developer feedback, and the most interesting part is how Microsoft is using AI to convert code to Rust. During the recent Rust Nation UK conference, the CTO of Azure, Mark Russinovich, spoke about the widespread adoption of Rust across Microsoft products. He mentioned that Microsoft is adopting Rust mainly to prevent vulnerabilities, 70% of which are caused by memory safety issues. He pointed out that government agencies such as the NSA have released guidance to use memory-safe languages for low-level programming over alternative languages like C or C++, which are not memory-safe. And that's why he made his most popular tweet in 2022 saying that new projects which need a non-garbage collected language should not use C or C++, but use Rust instead. In this talk, he also said that 2 years before making this tweet, he actually enforced a policy at Azure that all new code that needs a non-garbage collected language should be written in Rust instead of C or C++. After making this tweet in 2022, Mark actually said that Satya Nadella called him and asked if he was serious about using Rust, to which he responded yes, he was definitely serious. In this talk, Mark goes on to explain where Rust is used throughout the Microsoft ecosystem, starting with Windows. Rust is being used to write firmware for Windows. It's also being used to rewrite components of Windows that have historically had a ton of security vulnerabilities, like Direct Write Core, which manages fonts. Mark pointed out that the Rust rewrite, besides being more memory safe, was also 5 to 15% more performant. Rust is also being used in the Windows kernel. For example, the GDI region in the Win32k component was rewritten in Rust. And Mark mentions we'll continue to see Rust adoption in the Windows kernel. Another place Rust is used is Microsoft Office. One thing the Office team did is rewrite a foundational semantic indexer and search algorithm from C++ to Rust. Here we can see the performance results after the rewrite. The Rust implementation is in blue, the C++ implementation is in pink. After the rewrite, they found that the Rust implementation was significantly more performant than the C++ implementation for the same query. And the Rust implementation was more memory efficient as well. The other place Rust is heavily used is, unsurprisingly, Azure. Given that Mark is a huge proponent of Rust, the Azure team has written a lot of components in Rust. For example, Calyptra, an open source hardware root of trust. The firmware for this root of trust was written entirely in Rust, and Calyptra is now being shipped in hardware by NVIDIA and AMD. Rust is also being used to write the firmware for Azure's integrated hardware security modules. Rust is used in Azure Boost agents to do any parsing code that processes data originating from a guest VM. Part of Azure's hypervisor called Hyper-V is being rewritten in Rust as well. Microsoft has open sourced a virtual machine monitor called OpenVMM, all written in Rust as well. The Azure team has also written Hyperlight in Rust, a brand new open source micro virtual machine that can start in literally microseconds. They've also built other components like the Azure Data Explorer in Rust and Drosy, a data processing platform that allows you to easily detect and react to database changes. The Azure team is so bullish on Rust that they actually recently released an official Azure SDK for Rust, so you can easily integrate Azure into your Rust code bases. Mark goes on to talk about the feedback from developers using Rust. Some of the things that developers like is the fact that if your Rust code compiles, then it's likely to work. There's reduced friction for writing tests. Rust forces them to think about memory management more. Rust has a rich ecosystem, and data races and memory safety vulnerabilities are reduced in Rust codebases. Now, some of the challenges include C++ interop, the lack of mature tooling that you would find in other languages, the high learning curve, the fact that Rust doesn't support dynamic linking, and that some features the developers rely on are not yet stabilized. But overall, Mark says that the pros outweigh the cons. And in general, he mentions that the typical developer experience at Azure with Rust is that they'll experience a few months of frustration until they hit a breakthrough and fall in love with the language. Now, probably the most interesting part of this talk is how Microsoft is accelerating migration to Rust. Microsoft Research actually created a C to safe Rust transpiler, and then used it to transpile the Cha-Cha-20 crypto algorithm from C to Rust successfully. Microsoft has also built a Python to Rust translator. Now, unlike the C to Rust transpiler, this translator actually uses AI to translate Python code to Rust. In the talk, Mark gives an example of this simple game written in Python. Using this translator, they're able to port this Python game into Rust code. And with their AI agent, this game actually worked in one shot. No errors, no bugs. Now, this is a very interesting and impressive use of AI, and I think it's going to drastically increase the migration to Rust. In general, I'm really happy to see that Microsoft is not only adopting Rust, but they're showcasing their results publicly. This is definitely a huge vote of confidence for Rust, and it will likely get other companies to start adopting Rust, which will lead to more Rust job opportunities. But let me know what you guys think about Microsoft's adoption of Rust in the comments section below. And if you want to get up to speed with Rust, then make sure to get your free 4-day Rust training at letsgetrusty.com/bootcamp. And then click this video next, which YouTube thinks you'll absolutely love. I'll see you in the next one.